Okay, number 2 is a very important question for the test. It says calculate dy dx at the point indicated, then write the equation of the tangent line at that point. So we've got these parametric functions t cubed plus t comma t squared minus 1, and then they give us the t value. So we're asked to find dy dx at our t value that's equal to 3. Now the biggest thing we need to remember for this problem is how to find the slope when given parametric equations. So we've got y prime of t over x prime of t, and into that we're going to plug in t equals 3. So this is actually pretty easy to do. We've got, just do the derivative of y and x separately. So the derivative of y, we've got t squared minus 1, that derivative is 2t. And the derivative of t cubed plus t is 3t squared plus 1. Into that we plug in t equals 3, and we get back 6 over 28, which would reduce down to 3 over 14. So that is our dy dx at our point. And now we just need to write the equation of the tangent line. So dy dx gives us our slope. So we have our slope, that's 3/14. Our next part of the tangent line is our point. When we are given parametric equations, we have to plug our t value into the x and the y component to get our x and y. So I'm going to do that. I'll plug 3 in for t. So we've got 3 cubed plus 3, comma 3 squared minus 1. That gives us the point 30, comma 8. And we'll use our point and our slope together to make the equation of our tangent line, which would be y minus 8 equals 3/14 times x minus 30. Okay, very straightforward. Now the second part of question number 2, this one's a little bit different. The information given to us is not the same as the last problem. We're still given our parametric equation, but instead of giving us a t value, we're giving a point. So we already know that x is equal to 0 and y is equal to 2. So our point is done. We still need to find our slope. Our slope, again, we're looking for that dy dx at our t value. But what is our t value? And that's the piece that's different about this. We now have to use our values for x and y and our equation to solve for t. So if we know this is the point, then that means that our x coordinate, ln of t equals 0 at some value of t, and 3t squared minus t equals 2 at some value of t. So I need to actually solve these and then make sure it's the same t value. If I look at this first equation right away, that jumps out at me that t is equal to 1. And what I'm going to do is I'm just going to verify that that works over here. And 3 times 1 squared minus 1, that does equal 2, so that checks out. So the t value that we're using for this problem is 1. That's an essential piece to get the slope. We need that t value. So I'm going to put that 1 in here, and then we'll do the same process we did in the last problem. We find dy dt, that is 6t minus 1. The derivative of ln of t is 1 over t. And when I plug in 1 into that, we get 6 times 1 minus 1 is 5 over 1, or my slope is 5. That combined with my point gives me a tangent line of y minus 2 equals 5 times x minus 0.